Well, good morning, everybody. I have the pleasure to be here to talk to you about two projects that we are working on at the University of Turin in Italy on the database understanding and optimization of university mobilities. As you may know, the Po Valley in Italy is one of the areas which is most polluted, and Turin in particular is a city which is critical from the point of view of pollution. Of course, a large university like Turin University, with a very big community of about 85,000 people, has a strong impact on the mobility of the city. You can see here the modal split that we derived from recent surveys. As you can see, the car use is not as high as other modes of transport, fortunately, but still 17% of people coming to university by car every day means if you report the percentage to the universe, about 13,000 cars on a full activity day. Most of Turin University is located in dense urban areas, and therefore parking lots are a sought-after commodity, and the demand easily surpasses the parking places available. So how to allocate these parking places in a rational manner to a lot of people requesting to access them. Here I've listed some of the criteria that you could use. Some of them are quite unreasonable, while others are quite reasonable indeed, and those are the green ones. We will see how using these last three criteria combined can be the basis for a reasonable way to satisfy requests for car parking, recognizing that some people have difficulties in coming with other modes of transport to the university, while other people can actually use alternative modes of traveling. To put this issue in a real context, let me introduce to you the project that we are dealing with. The background is that in 2012 we opened a new campus, a very large structure, and due to existing laws, we were forced to install some 500 car places inside the building. This large car parking inside our campus remained quite unoccupied for a long period. It had a very low fee, but it was not free, and people most of the times probably prefer to park without any cost in the surrounding area. Everything changed when in 2017 the city administration decided to place a toll on the parking in the neighborhood. This fare was much higher than our own fare for the internal parking, almost 7 times higher, and this of course caused a large increase in the demand for our internal parking, surpassing the number of places that were available. In such a context, we wanted to establish a new approach that went beyond the classical generic appeals to use your car less, to go in a rational and innovative direction, acknowledging that the levels of sustainability of the mobility of people cannot be the same for everybody because of logistical and actual constraints. And we wanted to establish new criteria to deal with the allocation of parking permits that were data-based, using all the data available to evaluate who deserved to have a parking permit and who didn't. To sum this up, we had three main goals in this process. The first was one of equity. We wanted to allow people to access the car parking if they really need it and disincentive all other people. We wanted to have an efficient process, allowing us to obtain information seamlessly from a web platform in an automatic and quick way. Finally, we had a goal of extendability. We wanted to establish something that could be replicated and used not only for our new campus, but for other university branches, as well as other contexts, even outside university. So our ranking criteria for those who requested the parking permit were as follows. First, family-related constraints. People have to move other people in the family who are not able to do it themselves before coming to university. Second, acknowledge that people who went to the expense of buying eco-friendly cars, mainly an electric car, should be allowed more easily to access the parking. And third and most important, we wanted to define a journey sustainability index. What I mean by that, you compute the time it takes to go from your home to the university location where you work or study with a door-to-door car journey. Then you compute time it takes coming from home to university with the best multimodal, if necessary, solution, which involves active mobility, public transport of any kind, including sharing. This information can be extracted from the routing engine, which the Piedmont regions already maintains for its own infomobility web platform. In the end, the index will compare the two times and will have a very high value if your best multimodal solution using sustainable means is quick if compared with the time that you would spend traveling by car. Otherwise, the index will be low valued when the journey by car is way faster than the best multimodal solution. In this way, if you have a very high value for the index, you're not entitled to obtain the parking permit, while instead, if you have a very low value of the index, it means that it's difficult for you to be as fast as with the car using sustainable transport, and then it's more reasonable to allow you to get a parking permit. The first preliminary version of the index is already in use. In fact, 2 years ago, a web interface was developed which showed to the persons applying for the permit the map of Turin and the area surrounding it, with a subdivision in zones of different colors, which are actually isochrones, which is to say areas where the time to reach the campus from that area is equal. These two isochrones, referring to the new campus, show you different colors based on 50 minutes each, showing how long it takes to get from anywhere in a single color area to the destination, both with the car and with a multimodal solution of sustainable transport. This is for the car, this is the isochrone map for the car, and this is the isochrone map for the combination of public transport plus active mobility. In this way, things are simpler, and we have already developed a way to rank people who apply for the permit to allocate the parking spaces. At the end of this process, the colors of the isochrones are transmitted to the university, and the difference between the colors of a single individual is the basis for the computation of the index. The index is in fact a function of the difference between the colors of the two isochrones referring to your home address. If the difference shows that the car journey is way faster, you get a low sustainable accessibility index. If the difference is close, you get a high sustainable accessibility index instead. In the second stage of the project, which is being developed right now and that will be ready by 2023, things will get much better because the distance will be considered precisely for each individual requiring a permit. So the timing for the journey by car and for the multimodal sustainable journey will be produced by the routing engine in a precise way. Moreover, we are working to customize the routing engine so that its way of working can be controlled from many points of view. For example, setting a limit on the number of kilometers, on the distance covered on foot, by bike, even by car, because of course if there's no connection from your home to the transport network which is close enough to do it by foot or bike, you can even go for a few miles by car and have a quite sustainable journey anyway. The time frame during the day can be in some ways controlled as well, and of course the public transport sections which are connected during the journey should be controlled in terms of how many connections you can have in your journey, how long they should last, and how far tops of different buses or trams or trains could be. Not only that, because we could go beyond simple time computations. If you want to understand how it is easy to go to the university with a sustainable solution, you could also evaluate the comfort and ease of the sustainable travel options. So, for example, if it takes a long stretch on foot before connecting to the public transport network, or if there is an availability of cycle paths on the way so that the bicycle could be a reasonable option, or even the frequency during the day of the public transport solutions, because of course, if you have just 2 runs a day for some bus or trains or something else, and nothing for the rest of the daytime, it's not that comfortable compared to the situation when you have, let's say, a round of the public transport service every half an hour. Well, let's now move to the second project, which is dealing with something different, but still related, of course, to mobility in universities. So here the question is sharing mobility used by the university community at the moment? Could it be used more by more people? At the moment, sharing mobility is not a very widespread used option. Surveys in the recent past showed that we are not going above the 1% modal share. So we did devise a procedure involving the community as much as possible to find the ways to increase the modal share of sharing mobility. First, we reviewed what were the services available in the city and in the metropolitan area. Then we invited these services to put forward some proposals for incentives for the university community. And third, the most important here, we launched a survey on the community about what interest there was for the sharing mobility option, what kind of incentives could be more interesting to the community, what kind of problems did they face using sharing mobility. After that, we analyzed, of course, the results. We communicated such results to the manager of the services, and finally, they put forward the final proposals for incentives. The survey focused on 3 different dimensions. First, which are the types more used. Secondly, the size of the market for sharing services in the university community potentially with the possible incentives. And third, what kind of improvements to the service and to the fares could motivate more people to adopt this solution for their journeys. The target was the whole community, but of course the main target was the people that were interested, at least potentially, in using these services. We got almost 4,000 responses, evenly distributed between students, faculty and staff. So let's have a quick look at what the survey told us. In terms of type, as you can see in these tables, car sharing is quite widespread. Scooter sharing is quite widespread as well, especially among students, and faculty members prefer bike sharing. Those are the figures for people who are using these services quite often. Another interesting result can be seen in the table in the lower left. Here we have the split between those who are users, non-users, or people who have tried but are not actually frequent users. As shown by the arrow, only 20% of the sample are actual users nowadays. Moving to the size of the potential market inside the community for sharing services, of course, the 4,000 people who answered the questionnaire were all potentially interested. If you're not interested at all, you wouldn't have answered at all as well. This is confirmed by the 2 tables here, where you have the percentage of people using services who are interested in facilitation and incentives by UNITO. As you can see, those already using these services are fully interested in some more incentives to use these services even more. People who have not used these services up until now are anyway in a very large majority interested in considering incentives to move to the use of these services. But what about the fares that people are willing to pay for these traveling options? In the graph to the right, you see a very interesting combination of the percentage of discount that we could desire and how many people would be moved toward the use of sharing services by such discount. If you stay below 20% level of discount, very few people in the interested community would be moved in this way. If you decide for a 15% discount, this would not motivate anything more than 10% of the potential market. You need at least a 20% discount. Regarding the length of the subscriptions, While students prefer the monthly subscription, of course, because they have a very uneven distribution of activity during the year, people working at the university are mostly favoring seasonal or even yearly subscriptions. Finally, the result at the end of the procedure was that there were 10 agreements activated with mobility services. These are shown in this table. As you can see, at least half of them trusted the survey and set their discount rate above the 20% threshold. The only thing that remains to say is that in the future, the university administration could consider some contribution in economic terms so that these incentives can be even more attractive to the community. Thank you for your listening and have a nice day.